My name is Maarten. I'm a data scientist at the Erasmus MC in the group of Peter Rijnbeek. So that means that I'm mostly on Darwin, which means running a lot of studies, which is great. And before I actually want to, I show you how to use treatment patterns, I actually want to take a moment to sort of go to 10 years ago, to 2014, where because this is the moment where a particular study started. So particularly this study, which is treatment pathways in chronic disease, led by Patrick Ryan and his colleagues, which looked at hypertension, type 2 diabetes, and depression, and looking at the pathways of treatments within those chronic conditions. So I see that the start date of the study was actually on the 5th of December, if these are American dates, and then closed on the 31st of December. So I really hope that these people didn't have to work over the holidays or on New Year's Eve. If so, I'm sorry. This study happened 10 years ago, and I want to take a look at what did it actually take to run a study like this 10 years ago. So I actually have a video recording of me scrolling through the code that Patrick wrote, which was last revised on the 8th of January, 2015. And where you can see here some descriptions and some parameters that you can set for the treatment pathway analysis that they wrote. And what you can see is that there's not a lot of things to set. You can set like some concept IDs for different treatments that you're interested in. You can set like a specific concept for a condition that you're interested in, and you can exclude some concept IDs where you're not interested in, and you can set like a min cell count. But other than that, everything is like quite set and robust, which makes it great because then you can run the same analysis across different databases very consistently. So if I play this video here, you can see it starts scrolling, and there's this bunch of SQL code. I'm not going to play everything. I will just skip ahead just to give you an idea of what this entire analysis looks like. And it's quite an intimidating wall of SQL, I think. If I scroll to the end, it's about 2,000 or 2,700 lines of SQL. So imagine for every analysis or study that you do, you have to write 2,700 lines of SQL. So in Darwin, we do dozens of studies a year. Imagining that dozens of times a year per study, it just becomes unfeasible. And thankfully, we've moved away from that within Odyssey as a general, in general. 2 years later, there was this wonderful publication that looked at these chronic diseases and these pathways. So as a shout out to that paper, as sort of an homage to what this package was built on. I actually downloaded the code and reran the hypertension part on IPSY, and with some data wrangling or with some minor alterations to the study code itself, not the SQL part, but the R part that actually translates to SQL. So that means some updates to database connector and SQL render. It actually ran fine within 40 minutes. And I was then presented with an output table, which I was then able to reformat into a current data structure that the modern treatment patterns analysis uses to create a sunburst plot like this. So this is hypertension from 2008, because IPSY started in 2006, but with the min cell count, it skips over those first 2 years to 2012, which is mostly overlapping with the study period in the study. And we could see all these treatments that occur within that period, and we could see various pathways occur. So the most first-line treatment is this hydrochlorothiazide medication within IPSY. And then the second line is metoprolol, and so on and so forth. So it was really cool to see that 10 years after this study was conducted or written, the code still runs pretty quickly, which is nice. I would then like to jump ahead a bit to 2021, where Patrick already mentioned a paper was released by Aniek Marcus, and she developed the first version of the treatment patterns analysis. She really formalized, based on the work of Patrick and his colleagues, the analysis into an R package, and really introduced a lot of new features into how these pathways are built. So several parameters that she introduced was, for instance, the idea of a minimum error duration. How long should one event last within a pathway to be considered for building the pathways? Should maybe different eras of the same mitigation be collapsed into one continuous era? Also, a combination window. What if two treatments overlap significantly? Should they be combined and be considered as like sort of its separate entity rather than separately? So there's all these parameters that give you a lot of control over how these pathways are built. So I think largely these parameters still exist in the current package, even identical names, except for maybe the period prior to index, which is like a look back period. This now goes in either direction, and you can offset it to look to use it as a look back or sort of a look forward to sort of shift the index date, because that can be quite important. A couple of years later, Aniek published this paper using treatment patterns, or her version of the treatment patterns package, to do a network study on COPD and asthma for various medications, which is really nice to see. In 2022, I started my sort of Odyssey journey, where I got hired at the Erasmus MC, and I started working in Darwin, and within Darwin, we wanted to onboard the treatment patterns package, which was sort of formally developed under Eden, I guess. So we onboarded into Darwin, and I'll have a list of what changed in the next slide. And then actually from earlier this year, we onboarded it into HADES, and now it's this sort of Darwin-HADES collaborative effort, which is really nice to see. And it's moving forward together. So I've introduced over 1,700 unit tests. So these are also behavioral tests. So this can be, here's a fictitious patient with some arbitrary pathways, which then we have a specific expected output for, run the entire package for this patient, or run the entire analysis for this patient, and then we expect a certain pathway. Treatment patterns is also available on CRAN since 2023. And like I said, in February this year is also part of HADES. And it is fully compatible with all the HADES supported database supported databases. So it includes Postgres, SQL Server, Snowflake, and all the others. There's also some CDM connector support that depends a bit on the ODBC implementation for DBI. But mostly you can use whatever you want, whatever you're comfortable with. So that's sort of the history of treatment patterns. And from this point on, I'd like to talk a bit like what does it mean? What is a treatment pathway? What does it mean, and how do you use it for your study, and how do you design your study around it, or and what are common pitfalls and what are things that you'd probably have to think about. So a pathway, or when we talk about a pathway, it really is a sequence of events. Usually we talk about medication. So for instance, the hypertension and chronic diseases study, we looked at, or they looked at hypertension and really what are different medications that treat that indication. And for person A, that can look like very simple, where a person for a set increment of time gets a specific treatment. Well, for person B, it looks far more sporadic. And these differences are interesting because you can see if people follow certain guidelines or if they deviate from it. And then this really sets you up to ask more interesting questions. So usually what we do is we look at a certain target cohort. So this is the study population of interest. And then within that target cohort, we'll look at specific events. So again, start cohort or target cohort with a start and end date. And this is the reference frame that we're interested in. So we have various events. And you can see that the events on the outer sides are not considered for this pathway study. This can also happen where a treatment or a event starts within the target frame, I guess, but can actually last a bit longer. The opposite, where a treatment starts before, but actually runs into the target frame, is actually not considered. So this is where your look-back period is actually quite important. So if you expect that people are treated a day before your index date, you probably want to consider the day before as well. I have 3 parameters that I want to look into more detail into. So this is the min error duration, the combination window, and the error collapse size. Just to highlight some. We won't go through everything or through all of them because it just takes too much time. So let's say we have a minimum error duration of 5 days, and let's say this D treatment for person 4 lasts 2 days, and these short periods for person 2, for A, and for B for person 3 also lasts 2 days. What would happen, right? So for person 1, nothing really happens. Our pathway remains A to B, treatment A to B. For person 2, B is just completely dropped because we deem it too short to consider for the pathway. For person 3, again, the B treatment is dropped because we think it's too short. And for person C, or for person 4, sorry, we actually deem it as not treated. So there is an asterisk there because the analysis says it's not treated, but this person may very well be treated. Also, what's very important to consider is that this person is not treated for the specific medications that you look at. So they might very well be treated for something that you're not even looking at. Error collapse size. So we've also seen this in the major figure from index paper before. Maybe 2 treatments that are reoccurring. So let's say A1 and A2, they are both treated with A. That gap might be small enough to say, let's say, okay, this person is just continuously treated for a specific period. So for this person, their treatment will be A to B. For person 2, there's a B treatment in the middle, so their treatment pathway will be A to B to A. And then for person 3, the gap is too long or too large, so the treatments will be considered as separate. So then we go from A to C to C. And then for person 4, again, it will just be one continuous treatment of treatment D. Sorry. Then we have our final parameter that we'll go over is the accommodation window. So really, what is the overlap of 2 treatments where we consider 2 treatments to overlap significantly? And how does that represent in the pathway? So for person 1, it's quite easy. There's no overlap at all. So again, we just have a treatment of A to B. For person 2, maybe, okay, that overlap is quite large. So maybe we do find it significant. So then we have treatment A to this combination of A to B, or A and B to B. And then finally for person 3, we just have A plus B because they overlap completely. For these parameters, usually we specify them in specific days, and how you specify them specifically is quite dependent on what specifically you're looking at. So for something more persistent like hypertension, you probably want to set these parameters a little bit higher and longer, because overall these the duration or the years of follow-up from hypertension can be up to 3 years, like we saw in the study from 2014, for instance. However, for an infection, this might last like 2 to 3 weeks, and then setting your minimum error duration to, for instance, let's say 30 days, you're completely missing any treatment. So that's something to consider. How do my treatments relate to my indication? Finally, also what you can see, or what you can look at, is to sort of flip the entire analysis on its head. And rather looking at a specific indication, you can look at a specific drug exposure. And then your indication can actually see, or you can actually see pathways of different symptoms from exposure to a specific drug. So here I put GLP-1 receptor agonists because they're kind of popular right now, but this could also be vaccines, where you say someone is exposed for like 2 weeks to a vaccine, or I deem someone exposed for 2 weeks after someone is being vaccinated. What are different outcomes that we're interested in? So that's sort of the more theoretical study design part of what I'd like to talk about. Practically, I will now talk about it more practically. So how does that really form in, I guess, code, I guess. If we won't look at any code specifically, I've visualized everything in like flowcharts and stuff. So if you're not really into our code, that's fine. So typically what we need is, in our database, we need a cohort table with a cohort definition ID, a subject ID, and a start and end date. Sorry, excuse me. So here we see 4 cohort IDs, 1 through 4. The first one being our indication, hypertension in this case, and then 2 and 3 are 2 different events of interest. How you generate this cohort, TreatmentPatterns doesn't care. As long as the table with these columns, which is pretty standard. If you want to define it in Atlas and generate it with custom SQL, that's fine. If you want to use Caper or Cohort Generator or CDM connector, that's all fine. So with our cohort table in hand, we also need another table to indicate which cohort is what kind of cohort. So here we have hypertension as our target cohort, and then we indicate the other cohorts as events of interest. Again, this could also be some other target with other events. It doesn't have to be an indication in drug exposure. So with these 2 things set, we have our database with our generated cohort table. We have our separate table that indicates the types of what each cohort is. We can then interface with the database using either a CDM reference from CDM connector or connection details from database connector. We then supply those to the compute pathways function with a set of parameters, some of which we've looked at. And this generates an output Andromeda object, which houses patient level data. So if you need to do any verification of a specific patient, this is where you would do that. So all the intermediate objects will be stored in there. This object we can then export to a TreatmentPatterns result object, which is in the later version of TreatmentPatterns, this R6 object, which has attached methods to export it or save CSV files or upload it to a database. We will look at that in a second. So really on the left-hand side, you have everything that you do sort of outside, and everything on the right-hand side, we have everything that we do with TreatmentPatterns. So from this result object, we have some files or some tables, I guess, that specify some metadata about the analysis. So arguments, some metadata, some CDM source info from what the CDM was, where the analysis ran on, an attrition of people that got filtered out. Also some counts with per age, sex, and index year, and the two main results, which is the summary event duration and the treatment pathways, which houses the actual pathways. Excuse me. So the summary event duration houses some duration information about the individual treatments, either combination treatments or individual treatments of each step in the pathway. We also have some functions or some methods attached to this output object. So you can actually make an empty object and load from a zip file or CSV files and generate the object. We can save it as a zip file, we can save CSV files, or we can upload the results to a database. And then finally, we also have plotting functions to plot the event duration, which is just box plots per treatment to see how, to sort of summarize the duration of those treatments, the sunburst plot and the Sankey diagram. So this is the image that we saw before as well for the hypertension study. So really, how do you read? So one big caveat with these is that there's no time indication. So this is where the, let's go back to plot event duration sort of comes in hand to see, on average, how does one of these notes take per person? And then also, does it per line of treatment, for instance? So that's one giant caveat. So there's no time indication from these sunburst plots. And why? Because you need to collapse these pathways for groups of patients to visualize it in one plot. Another visualization, which I tend to not use that much, is the Sankey diagram. Generally because I think they get quite messy with the amount of pathways. So if you only have a relatively restricted number of treatments that you're looking at, and they don't jump around that much from one treatment to the other, they're quite nice because they're quite nice to follow to see how the pathway progresses. But for larger pathways, or for more larger data sets like this, I do tend to prefer the sunburst plot. And that's my presentation about treatment patterns, and I hope this was informative. And if so, if not, I'd like to hear why. Thank you.
That was definitely tremendously informative. Thank you, Maarten, for going through that. While you were presenting, one question that came up in the chat was that you touched on very briefly was about duration of time spent in the events. Kevin posted that. Kevin, do you want to just share a little bit more context about your question and what you're looking for, and then maybe Maarten can talk a little bit about the event duration table in a little bit more depth.
Yeah, great presentation, great overview of the package. Really looking forward to experimenting with it, especially as we look for, our evidence generation, the Crohn's and colitis analysis that we would want to do. Duration is obviously really key. I get that you can't get it out and present it well, but is it left behind in Andromeda for potential further exploration? I get that it's very hard to visualize duration in the different events.
Yeah, so all the patient level data is still in the Andromeda object. So that also means that there's a record per person per treatment. So if someone has 3 treatments in their pathway, there's 3 records for that person, and then the start and end dates are just there. So you can from that get the duration of each treatment and do whatever you want with it from that point on.
And then next question, could you do it by calendar year, right? So you see the sunburst, starburst plots 2002 to 2018. Yeah. If you knew that in 2019 or 2018 or something, there was a major change, could you do very easily pre and post?
Yeah. So in the result, there's actually an index year by default. So it has the pathways per year. Or per index here as well, yeah.
Well, I think I missed a half step there, Martin. Can you describe again the summary event duration table? You had that on one of your slides in terms of one of the artifacts. Could you just describe a little bit more about when is that generated and what does it contain?
I actually have a plot I just opened the VIet. I think that's easier because then, so this is what it looks like if you see my screen. So this is one of the plot that it generates. So here we have different lines of the pathways. So this is the first line, this is the second line, and this is across the entire pathway. And then so there's also mono events only. So this is treatments that are not combined and combination events as well. And then we see the duration of those mono events, combination events, and each individual treatment or combination treatment that was picked up by the treatment patterns analysis. And then we can see it generates box plots on how long each treatment took. So you have a minimum, a maximum, and then the median, and then the Q 25 to 75 as well. So this gives you some of an semblance of how, or an indication of how long each treatment took, or event, I should technically say, if that makes sense.
I think that's clear. I'm just trying to connect it to Kevin's question, what he's looking for. So, Kevin, can you just remind me in the context of your guideline-driven evidence study, because you were talking about duration at the steps. Like this looks like it's giving you duration on each treatment if you were first line, and then duration if you were on second line. Is that meeting your need, or is there something else you were thinking through?
It might. I might have to explore it a little bit more. I mean, the hardest thing I think with some of the biologic stuff is figuring out switch when it could take sort of 90 days to see that that it's not really add-on and switch. That gets a little bit challenging, but it looks like this package is flexible enough to handle a lot of that. But yes, duration in first step, duration in second step, that's some key functionality.
Very good. Cindy, you asked a question about the target cohorts and how, and that's something that we specify as the target cohort in Atlas or somewhere else. You want to come off mute and provide a little bit more context for your question, and also remind Maarten about the your intended use case for the treatment pattern study for your diabetic retinopathy screening study?
Yes. Thanks, Patrick. So we're looking at whether patients with diabetes are getting 3 different types of diabetic retinopathy screening, which are basically one-day event repeat outcomes. And my main question is just when we construct the target cohort of adults with diabetes, I want to only focus on patients with diabetes that we have follow-up for 3 years. Do I do that in Atlas, or is that something I can specify in the treatment pathways package? I'm just trying to figure out where I need to do what to, create this strategist analysis specification.
So it sounds like for your specific case, I would intuitively go to Atlas and just say, go from the indication and then go from there. I don't know. What will you do, Patrick? I think you have a good, as an advanced Atlas user.
I think your package is flexible to do it either way. I guess maybe just to add to Cindy's question, so particularly given that the event cohorts here are a series of basically like one-day procedures that could occur. Cindy, in your context, we're primarily interested in like annual screening rates, right? So we're really thinking about, for somebody who's a diabetic, following them for a year, did they get one of these screening procedures is primarily the thing that we're trying to, and which of the procedures they got. Do I have that right?
Yes, and I think for that question, we can probably use the cohort incidence package. And I think I wanted to look at treatment pathways just to see if patients who are screened initially with AI, are they going into the office afterwards? So that change is what I'm hoping to capture with the treatment pathways package.
Yeah, that makes good sense. Yeah, and I think I agree with Martin that like having the cohort be set for whatever follow-up time, that way you'll be confident that when you say, did they have that follow-up to the office after the AI visit, you'd know that it's not because they're just like lost to follow-up. That was actually one of the gotchas in the. I appreciate, Martin, you embarrassing me by showing the original SQL code for the original study. But one of the big gotchas we actually had was not appreciating that it's important to define follow-up time in one of these treatment pattern studies, because otherwise you'll end up with sequences that terminate, and you don't know whether termination is due to no other activity happening or basically due to loss to follow-up. And it's a useful thing just to think through. There can be circumstances where it's okay to be lost to follow-up if you're thinking through things, but there may be circumstances, like I'd say, Cindy, in your example, where it's like you kind of want to understand, like, given people who had an opportunity for a full year to have something happen, did it happen in the year? So you want to actually impose that follow-up time, whereas for other types of activities, we can accept the fact that there's loss of follow-up. In the original study that we did with hypertension and diabetes, I actually screwed up and didn't require follow-up time in the very, very initial code. And what we saw was that there was tons of extremely short treatment patterns, like they didn't make plausible sense. And the reason was because we didn't actually require that people continuously be treated. And so one of the things that Martin thankfully hid from you all, but in terms of like a nasty little detail that we had, is we had in our target cohort a requirement that not only they have hypertension, but they had to have some drug every 3 months. And we required that them be on some drug every 3 months for the full 3-year period of time. And that was basically as a very ugly proxy for somebody who's on continuous treatment without regard to what the treatment is. And that was specifically to really get a more I think fairer picture of what was happening, because the pictures prior to that were quite bright. And Kevin, to your point, so immortal, so like specifically we were not including people who didn't have the full follow-up time. So you could absolutely think like, so that meant a hypertension patient who initiated their first-line hypertension. If they did die within the first 3 years, we were not including them. So you could consider that some sort of like potential bias in our population. In our context, we felt kind of okay with that because we were trying to start on first-line treatment of non-serious, chronic diseases and understand what happens. But yeah, this is why I think it's super important that we have the treatment patterns package that Martin's authored to allow us to have some parameters and to think about how you can pass in different inputs, so that you don't get yourself kind of trapped into some of the mistakes we made 10 years ago. Other questions or comments from the community for Martin? Martin.
Well, first of all, Martin, great job on this. I look forward to using this package in studies. So a question more for like a performance standpoint. So I missed first 10 minutes of this call, so I may have missed you saying this, but have you tested this package on like a large claims database? I remember in the previous iteration of the treatment patterns package, depending on how you designed it, held it like kind of bad designs, but it would kind of crash on like large US claims databases. So have you tested this package in like kind of these larger databases? And the other aspect is, are you doing all of these, like when you're doing the alignment of the patterns for the patients, are you doing this on the database, or are you pulling this down into R and manipulating it in memory?
So the second question is the quickest to answer first. So I pull down everything into Andromeda, whatever I need first. So this makes it kind of nice in a way where you make your connection to the database once, you pull everything we need from the database, and then it just runs in Andromeda. And then it is also not capped by memory anymore. For performance, for your performance side of that question, is Martijn at some point tried to run treatment patterns with like 56 event cohorts, and that's what. So first of all, that's your result gets pretty uninterpretable, and second of all, is that that is the major thing that treatment patterns scales off in terms of like computation, because all the steps that you or because it inflates the amount of possible pathways that are possible with those and combinations. It increases those possibilities by like n factorial or something. It's crazy. So the quantity of people is actually it shouldn't affect it that much, but it's really like the amount of event cohorts that you look at that really introduces issues.
Right. Yeah, that's what
I'll just say that I think Maarten's being a bit humble here in that Anique had written an R package initially, and she did a great job of kind of like having a proof of principle, and she did a wonderful job with it. But Maarten's done an amazing job with optimizing that package to make it so that it, withholds the rigor of passing all of our unit tests and working in different environments, and did a lot to make it much, much more performant. So Maarten, if you had played with Anique's initial version, I would give Maarten's new version a run, because he's done an extraordinary job of really gaining a lot of huge efficiencies to make this possible.
Yep. Yeah, I look forward to it. Thank you.
Mark, since I see you on the screen and you commented about the use in VA, could you just comment a little bit more about your initial experience with using the package?
Well, I'd certainly like to defer to the individuals that did, if Bill or Ben are here and like to say a word or two. If I'll give them 10 seconds if they're here. Otherwise, I'll chime in.
Sure, I'll comment briefly. Hi, everybody. So we have successfully run this package in Veterans Affairs claim databases. We've done a couple different versions. I defined a cohort of people initially diagnosed with depressive disorder and characterized the treatments of, I think, 18 or 20 different medications over a couple of years. It takes a few hours, but computationally, it seems like we're pretty okay.
That's amazing. Thank you, Bill. And particularly for you at the VA to say it only takes a couple hours means that everybody else should feel extremely happy about what that could mean for them.
That's true. I deliberately kept the, I guess it would be the target cohort interval kind of short, just to get it to run. So we did like 1 year after entry into the cohort. But we will stress test it and find out how it goes.
It's awesome. It's really great. Anybody else have any thoughts or comments on the treatment patterns? So I know, Maarten, that there's at least 3 of our guideline-driven evidence studies that we're waiting on your presentation to be able to configure things. So I know Kevin and Cindy were 2 of them. I think there also is interest in using this for pediatric vision screening, and I think there's one other that I'm forgetting off the top of my head. So I know we'll be able to count on you as everybody jumps into using this to embed them in their studies. But it'll be really nice to see from your kickoff and introduction here to be able to see it into action for a bunch of Odyssey Network studies. Oh, Gigi has posted a question. Gigi, you want to come off mute and talk about your interest in chemo cycles and recurrence?
Yeah, we've got a couple thousand patients with glioblastomas, and we're trying to look for patients who have basically recurred after 5 rounds of TMZ, and it's been a real challenge to try to figure out the 5 rounds of TMZ.
Rashad, have you had any experience in Darwin or elsewhere in thinking specifically about like chemotherapy regimens? Have you used the package for that yet, or is anybody else in the community?
Yeah, so we specifically sort of so within Darwin, we have one study that looked at like chemotherapy and immunotherapies for late stage cancer. And then I think for the chemotherapy regimens, we actually specified just a specific period where we just said, okay, this is just the first line of treatment. So we just let treatment patterns do its thing, and then just said, okay, this is just a combination therapy of like all these things that pop up of interest. But other than that, no.
Well, that's
Can
a really
you direct me to
interesting
that?
connection. But
I don't think
Yeah.
it's published yet, but should be soon.
Well,
yeah, this seems
So-
like a very nice touch point with our oncology work group and the work that's been done to try to develop a line of therapy algorithm where the fundamental challenge of defining regimens is figuring out the sequence of combinations. And I know that there are some peculiarities as it relates to cycles in chemotherapy that make it maybe not as straightforward as just first, second line of a individual products, but it seems like a really good opportunity for collaboration there and take advantage of the new tools to explore that.
appreciate it.
And then Kevin, you had an additional follow-up question about the visualizations.
Or whether it's in Strategos or not, is there a shiny dashboard visualization output?
So within Darwin, we do have our own Shiny modules for all our Darwin packages. We haven't really thought about yet on how to, because obviously there's also an Odyssey Shiny modules on how to integrate it in there.
Okay.
But worst case scenario is just copy paste it over and it should work. So, but there are some public modules out there that I can point you to.
I had
Maarten?
another question. So you mentioned, Maarten, that you had a like patient level table that comes out of this before you put in like say summaries, apply like summaries and plotting to it. So that table, you say you have the like the target start date, you show like the event, the sequence of the event. Does it also show the date of the event or like the time, like the event start date and event end date?
Yes.
Okay,
Yep.
Very good. Well, I have a lot I could do with this. Thank you.
Very good. Any other questions or comments from Maarten? All right. If not, thank you so much for presenting and for all of your contributions and leadership in getting this tool developed and into our HADES ecosystem for folks to be able to take advantage of. I know as people are jumping in, they may reach out to you for more questions, but really appreciate your leadership in maintaining this package for our community. Thank you everybody for coming and for listening, and look forward to seeing you all next week. Have a great weekend and talk to you all soon. Bye everybody.